Triangles Theorem 4. If in two triangles, sides of one triangle are proportional to the sides of the other triangle, then their corresponding angles are equal and hence the two triangles are similar. This is somewhat opposite to the theorem number 3. Alright. So I gave you a hint that starting with if and the comma, it is given. After that, to prove. So let me take the help of the two triangles as usual. This is triangle A, B, C given. And another one, the bigger triangle. This is D, E, F given. D, E, F. Alright. And what is given to you here? Given that triangle, these are not similar. We need to prove the sides are in same proportion here, right? So they have given you AB by DE is equal to AC by DF is equal to BC by EF. BC by EF. So this is what given to you. All right. That's what given. Now what to prove? Let me write here. To prove. I need to prove that angle A, so look at this, then their corresponding angles are equal. That you need to prove. Angle A, you need to prove is equal to angle D. Okay, so this is, let me write 1 here. All right, this is 1. What I need to prove? Angle A is equal to angle D. And what? Angle B is equal to angle E. And angle C is equal to angle F. So A is equal to D, B is equal to E, C is equal to F. I need to prove this. That's what they ask you. Then their corresponding angles are equal. And hence, the two triangles are similar. So I need to prove that triangle ABC is similar to triangle DEF. I need to take you to theorem number 1. In theorem, not theorem number 1, theorem number 3, the previous theorem. Alright. What we had there, they gave that all the angles, corresponding angles were equal, they said, isn't it? Angle A is equal to angle D and angle B is equal to angle E, alright, and angle C is equal to angle F. This is what they gave. And what we did, how we proved that the two triangles are similar? By SSS, alright. Even if we would have used SAS when they give you AAA. But in this theorem, what you find here, they have given you SSS. That means we must prove that they are similar either by AAA or SAS. Remember this point? Do not forget. Got it? So let us proceed here. Now, in the previous theorem, we did one construction. The same construction we are going to use it. Okay. Cut DP is equal to AB and DQ is equal to AC. Join PQ. That's the same construction we follow. So I'm writing here what? I'm writing here construction. What is that construction here? Cut DP is equal to AB. Alright. And not necessary and you can say DQ is equal to AC, DQ is equal to AC, and what are you going to do? Join what? PQ. Join PQ. We are dealing with a basic proportionality theorem, so that's the reason why you need a line parallel to one side of a triangle. Alright, here, that is the idea behind this construction. Got it? Now, what to do here? If you check here, what they gave you here, check it out here. AB is equal to DP, all right. And AC is equal to DQ. That's also all right. Now we joined PQ. Now can we anyway prove that PQ is parallel to EF? Of course we can prove by taking what they have given. What they have given you, AB by DE is equal to AC by DF. Okay, AB by DE is equal to AC by DF. This part of given I will take now here, right? In what? In proof. All right. So I'm taking this. Why I'm taking? Let me explain you. AB by DE is equal to what here? AC by DF. AB by DE is equal to AC by DF. What is this? This is given, right? Now, what is AB is equal to? DP. I can write DP here. And what is AC is equal to? DQ. I can write DQ there. So, what I'm going to write here? Or, instead of AB, let me write here DP by DE is equal to, what is this? AC is equal to DQ. This is DQ by DF. All right here. This is by what? Construction. This is by construction. Now, study this one over here in this triangle. DP by DE is equal to DQ by DF. That means you can take the converse of BPT. What is converse of BPT? If a line divides the two sides of a triangle in the same proportion, then that line is parallel to the third side. So with the help of this, we can take PQ is parallel to EF. Isn't it? So let us write that first, then let us proceed. Got it? So what I can write here? Okay. So therefore, what? PQ is parallel to EF. How? By converse of BPT in this triangle. Got the point here? Now, why we took this PQ is parallel to EF? With the help of that only, we are going to prove that the corresponding angles are equal. But how? We can see that P is equal to E, corresponding angles, and Q is equal to F, corresponding angles. All right here. So therefore, what I can write here? Angle P is equal to angle E, and what? Angle Q is equal to angle F. Reason, okay, let me take it here, 1. And what reason shall I give it here? Corresponding, what? Corresponding angles, because PQ is parallel to EF. PQ is parallel to EF. Now, check here. What I need to prove? A is equal to D, B is equal to E, C is equal to F. So I proved that P is equal to E. If I prove that B is equal to P, then B is going to be equal to E. Simple. I proved that Q is equal to F. If I prove that Q is equal to C, then C is equal to F. Proved. And when the two sets of corresponding sides are equal, the third set is automatically equal. Proved. So when this is done, then both the triangles are similar by AAA similarity criteria. Simple. So they gave you SSS and we proved by AAA. That's it here. Understand? So let us proceed. Now question comes here. How do you prove that P is equal to B and Q is equal to C? How can you prove? When you prove that this triangle and this triangle are congruent. When these two triangles are congruent, then B is equal to P, C is equal to Q. Prove that the problem is solved. Isn't it here? How to prove that these two triangles are congruent? We can prove it by SSS. How? AB is equal to DP by construction. AC is equal to DQ by construction. We need to prove that BC is equal to what? PQ. If you prove by SSS, these two triangles are congruent, then problem is solved. So how to prove that BC is equal to PQ? Because we know already two pairs of corresponding angles are equal. Let us prove BC is equal to PQ here. Now check it out. Let me come to this point. Because PQ is parallel to EF, I told you in the previous theorem that by corollary of BPT, you can take DP by DE is equal to DQ by DF is equal to PQ by EF. Yes or no? Corollary 3. Try to recall. Okay, if not possible, I explained you twice. Okay, in the previous theorem as well as when I was explaining you theorem number 1. Go back and check it out. That is what the way you need to do revision and study. Got it here? Now what I'm going to take here, check here. Okay. Okay, PQ is parallel to EF. We got it. PQ is parallel to EF. Okay, proved. Already proved. So therefore, what I can take? dP by dE. dP by dE is equal to dQ by dF. dQ by dF is equal to what? PQ by EF. PQ by EF. By what? By the corollary of BPT. The reason you need to give. But what is this? What is this given? AB by D is equal to AC by DF is equal to BC by EF. We are going to compare these two and prove that BC is equal to PQ. Shall we prove? Now check it out here. What is DP is equal to? AB, isn't it? DP is equal to AB. So instead of DP, write there AB by DE is equal to. DQ is equal to AC. Use that. Instead of DQ, what you put there? AC by DF is equal to, what is that? PQ by EF. Now compare this and the given thing. What is given thing? Check it out. What is given to you here? AB by DE is equal to AC by DF is equal to BC by EF. Now, AB by D is equal to AB by D, right? AC by DF is equal to AC by DF. That means what? PQ by EF is equal to BC by EF. These two equal, right? Now check here. 1 by EF get cancelled. So you get here PQ is equal to BC. There you are. I got it. PQ is equal to BC. Now what I can do? I can prove this triangle and this one congruent by Sss congruency criteria. Isn't it? So let me write that for you here in this place. Right? Shall I do that here? Now check it out here. So in triangle, what? In triangle ABC, and triangle what? And triangle DPQ. AB is equal to DP. Number 1. AB is equal to DP by construction. AC is equal to DQ by construction. AC is equal to DQ by construction. BC is equal to PQ. BC is equal to PQ. Proved. Right? So these two are by construction. Alright. And this one is proved. Here it is proved. So what are you going to write here? So therefore, you are going to write triangle ABC is congruent to triangle DPQ by what? By SSS criteria. By SSS what? Criteria. Now what is the use? We need to prove the corresponding angles equal. Isn't it? We already proved that. What? We proved somewhere over here. Have we written? Okay, here. P is equal to E we have taken. P is equal to E we have taken. Understand here. Because these two are congruent, so B is equal to P. But P is equal to E, therefore B is equal to E. This is what we need here. Right here. So what I am going to write here? I have written here what? I have written here 1. So let me proceed here. So therefore, what I am going to write here? B is equal to P. B is equal to P. Angle B is equal to angle P. CPCT. And what? And after that, C is equal to Q. Isn't it here? Angle C is equal to angle Q. What are these? CPCT. Okay. Now when you compare from 1, P is equal to P, therefore B is equal to E. Q is equal to Q, therefore C is equal to F. Understand here. So here we proved P is equal to E, but there we proved P is equal to B, therefore B is equal to E. And here what we proved? Q is equal to F, but there what we proved? Q is equal to C, therefore C is equal to F. Understand here. So this is 2. Alright. So I am going to write here from 1 and 2. From 1 and 2, what we can do? We can straight away say angle B is equal to angle E, comma, angle C is equal to angle F, and I can write here angle A is equal to angle D. What? If two pairs of corresponding angles are equal, then the third pair is automatically equal, because any triangle you take, the sum of the three angles is 180. Okay, so you can write here third angle property. Third angle property. This is what you can write. You can write third angle property. So there we proved this. And what you can write here? So let me write here, because there is no space. I'm writing here. So therefore, the two triangles are what? Similar. How? By AAA similarity criteria. Because the corresponding angles are equal, isn't it? A is equal to D. So there you are. B is equal to E. There you are. And C is equal to F. There you are. So therefore, triangle ABC is similar to triangle what? Triangle DEF by AA similarity criteria. Got it, children? Practice well.